On this problem, we're supposed to find the open t intervals where the curve is concave up or concave down. So, for concavity, we'll need to find the second derivative of this plane curve. Let's begin with the first derivative. So, the derivative of the parametric curve will be dy dt over dx dt, which is that. We can factor out the t, so we have 2 plus 3t over negative 2. All right, we have the first derivative. Now we're going to find the second derivative. And the second derivative is the derivative with respect to x of the first derivative. What's going to be helpful is if you think of the first derivative, dy dx, which is dy dt over dx dt, think of that as the numerator being d dt of y, which is equivalent, all over dx dt. Again, dy dt over dx dt, think of the numerator as the derivative with respect to t of y over dx dt. So when we take the derivative of this function, we'll do the same exact thing. So we have the derivative with respect to t of, in this case, dy dx. So the derivative with respect to t of our previous dy dx, all over dx dt. And dx dt is exactly what it was the last time. Dx dt is negative 2t. So this is equal to, so the derivative with respect to t of this expression is negative 1/2 factored out, and then the derivative of 2 plus 3t is 0 plus 3. And the denominator is just negative 2t. Do not use the quotient rule here. We do not have a ratio of two functions of t. Just do it like that. All right, so now the negatives cancel out. We're left with a second derivative of 3 over 4t. All right, now that we have the second derivative, we can find the open intervals where the curve is concave up or concave down, because we know that it's concave up when the second derivative is positive, and the curve will be concave down when the second derivative is negative. So it's concave up when t is positive. It is concave down when t is negative. These are indeed open intervals. We could also say when t is a member of this open interval for the concave up, and when t is an element that belongs to this open interval, Finn, no thank you. Or the way the textbook expressed it, an open interval from 0 to infinity, or the open interval from negative infinity to 0. These are all fine.